Hello, I thought it would be interesting to have a walkthrough of fixing an issue I found in my PCB project, the Neotron Pico. We're just about getting ready to ship version 1.1 to our Neotron beta program members. I created the 1.1 release candidate and then I immediately found an issue. So let's fire up KiCAD and see if we can fix it. So this is the website for the Neotron project. We can click through, show me the source code, will take us to the GitHub page, and the project we want is the Neotron Pico. Here's the board, and there's the README. And if we look at the issues, the one I want to fix is this one, number 145. Yep, I did some tidying up. I moved some vias around, and I had the silkscreen layer switched off. I don't seem to have a design rules check which complains about overlapping vias and silkscreen, but I was looking through the Gerbers in my Gerber viewer and I saw oops, so let's fix it. So here's KiCAD. We can open up the schematic. I'll resize that, just give you some sense of what we're looking at. So the schematic is a hierarchical schematic. We've got our processor, video circuitry, I/O expander. This provides the chip selects for the system bus. We have 8 chip selects, 8 IRQs. This is our expansion bus. This is where the expansion slots are, and the 2 devices we have on the bus: board management controller and our SD card. Audio codec, clock, power supply, fairly basic stuff. But today we're not really looking at the schematic in detail because what we need to fix is the PCB. So that has come up far too large. Let's move that up into corner, make sure we get it all on screen, something like that. So there we go. So there is the board. We are on the top layer. We have middle layer. Middle layers are just ground. It's a 4-layer board with 2 ground planes in the middle too. We have a 3.3 volt pour on the bottom, and we have no pour on the top. Just some stitching vias going right through. Okay, so if we have a little zoom in over here, let's see what I've done. I moved this net tie around, I made it neat and tidy, and I've gone and dropped the 3.3 volt via right on top of this reset label. Don't really want to move the reset label, so let's move this wire across. Let's rotate this net tie, drop that there, and delete trace. Just going to drop that down underneath. Yeah, so annoying problem. I've set this entire board up to run on a 12.5 mil grid because it's mainly through-hole parts. You may notice this expansion slot is off-grid. That's because I need to conform to the ATX specification, get the expansion slot to line up with the case. Yeah, in general, everything on the board is on a 12.5 mil grid. Parts like this net tie, we can center it on the grid on this axis, left to right, but if I wanted to put this via underneath, it's then going to end up awkwardly not quite in line to the left or to the right, which is kind of frustrating. How do I want to fix this? I could put the via at the end, and it won't let me put it on top of this trace here. I don't really want to stretch this SCL trace any further, so I'm just going to put the via underneath, and then we're going to connect it up with. This is the change I was going through and making nice fat traces. Oh, that's a bit thick. What are we using here? Down at the bottom it says 16. Okay, let's make that. Yeah, it doesn't look great, but I think that's going to work fine. We could bring the via up like that. Just compare it to the others. Yeah, the others all get to be straight. I think that'll do. I'm not too fussy. I am very fussy about board layout. I could spend hours nudging and moving and pushing things around, and I shouldn't, because I have better things to be doing. Okay, so I'm aware there was there's another one here. What do I want to do with that? I can't put the ground at the end. It's going to run into the 3.3 volts. I can put the via on the corner. So I initially started with a lot of the vias out in the corner, and I stopped doing that because I didn't think it looked too good. I thought it was nicer when the vias are straight. One reason for putting the vias on the corner is it just gives you a bit more space. So now these look mismatched. It doesn't make any difference electrically. I just feel better when everything's tidy. And now, cascading series of changes to make all these consistent. I'm going to end up doing that. That is the part number for the connector. So that's fine. That can go over here. Yeah, good enough. Look at the bottom layer. That's the reason that stub's there. That's the SPI bus. Okay, see if we can see any more. Just going to sort of zoom in and out around. Here's the VGA DAC. Yeah, the hole is not going through the silk screen there, so I think that's fine. I think the previous board was like that anyway. Let me have a look. I have one here. Yeah, that seems fine. Arm 1 and 2. Scrolling around. There's a lot of stuff in the board management controller area. Let's have a look back in the issue. Actually, I may have noted R1004. So 10 is on page 10. 1, 2, 5, 6, 7. R1004 is up here. Yeah, so that is the keyboard signals coming out of the microcontroller. We can, in this case, just move the silk screen. I think that's going to be fine. Scroll down, those look okay. Power supply circuitry. So we have 12 volts come in. It goes through this pi filter, cap, inductor cap. They're big 100 UFs, I think. Yep, 100U. And then it goes into this Monsun 5 volt 3 amp switch mode power supply module. So we get a nice 5 volts out of here, and then we run the 5 volts up to this 3.3 volt regulator, and then this powers most of the board. You see there's lots of stitching weirds in there. That all looks okay. That one I put the via under the MILF. That should be fine. When I say should be fine, I'm not a PCB expert. I'm a software engineer. I don't particularly know what I'm doing, which is why I thought it would be interesting to record this, and we can just have a little wander around the board, talk through what I've done. Here's the transistor that drives the PC speaker. We've got buttons and LEDs, along with 2-pin connectors for connecting up your case. 5 volt trace annoyingly had to drop under the board to skip over all of this stuff. It seemed better to send the power down to the bottom layer rather than all of these signal traces having to dive down and come back up. Real-time clock circuit. Oh yeah, here's another one that's a bit close. Get that one to line up. These are just the solder bridges, so you can choose what voltage to apply to your real-time clock. There's a couple of different SO8 real-time clocks you can fit here. Microchip 7940N, or this one I think is currently set to be a Dallas semiconductor. I think that's what, yep, DS1307Z+, so that's what the manufacturer will fit, which means you need to solder the 5 volt bridge instead of the 3.3 volt bridge. But if you order a bare board, you get to choose. Looking over here, I now just spot that this trace has a kink in it for no apparent reason. There's no reason that can't be a straight line. Silkscreen will sit on top of a trace, no problem at all. There's nothing much in this corner of the board. I deleted the stitching vias so they don't interfere with the silkscreen. So let's go up and look at the expansion connectors. Yeah, that one seems fine. Traces. It's mainly these net ties, the vias I moved around. Previous version of the board, these parts up here were far too close to the slot. I didn't check the 3D mode carefully enough, and so what happened is when you went to solder the connector down here, the leg of the connector actually sits right about here, and that's where the components were. So that didn't work. I had to chop the leg off my connector. It was still soldered down okay, but I had to chop the leg off to avoid fouling that resistor. These resistor capacitors, they're just they're there in case you need to lower the slew rate on the high-speed buses. So you could fit a small value resistor and maybe a capacitor if you wanted to round off your square wave, make it slightly less square, you get less high frequency components. That's an option for EMC in the future. I don't think I changed much here. That all looks relatively neat. Incidentally, I'm just scrolling by holding down Command and Option and mouse wheeling my way around the schematic. I find that works quite nicely. Either that, I'm sort of forever zooming up and down and in and out. Again, I've got a weird kink on that trace. There was no need for it to do that. As I said, I can spend hours fiddling around with PCBs, moving all the traces. Ah, here we go. Here's some more. Where do I want to put those? Yeah, I think that looks fine. I think that's fairly clear which ones they are. You could put that. You could put that up there. And then where would you put that one? Down here, I suppose. And then that one should probably go underneath like that. I don't know if I've made that better or worse. Right, that's the one for the chip. That's the one with the ferrite bead. That one needs to move up there. Turn off the bottom layer, I don't need to see it. And let's bring the silk screen to the top. You know what I'm going to do? I'm going to put a little line in there just to make it clear that that's the chip. They've all got a dot for the number 1. So that's the chip. Capacitor, ferrite bead, capacitor, capacitor for the crystal. Pull down resistors for, I don't remember what those signals are. Let's go back and look at the schematic. So if you didn't know, when you're in KiCAD, in the PCB editor, whenever you click on a part, the schematic automatically jumps to the part. Mode and CS pins are tied low because this is in I2C mode with the first address. First version of this PCB, I forgot to put those in. The mode pin, I think, was flapping, or the CS pin. One of them I forgot to pull. I think it was the CS pin, which meant it was randomly changing between the two I2C addresses, and you couldn't talk to it. Looked fine when I was drawing it. I didn't realise they didn't have internal pulls. Right, here's another example of why sometimes sticking the vias on the corner just works better. Select the top layer. If I stick that, the reason I changed them was because if you don't get them quite right, then you're going to end up with these sort of weird angles between the trace and the pad. And And now I'm struggling to get this back where I want it. Is that in line with that one? Yes. Trace, what are you doing? And then sometimes the traces just have a mind of their own and you have to go, nope, I would actually like to start there and go in there. I think that's okay. I don't think too much of the solder is going to fall down that via. Let's have a look at the 3D view. 3D viewer. Started up on the wrong screen, so let's go and grab that. So here we are, and we were looking at these parts over here. So yeah, I think they're 0805s, so they're enormous, and I think they're set to have hand soldered pads. You can choose different kinds of pad size. That component is change footprint 0805 metric pad hand solder. Right, so the pads are all sized for hand soldering, so the pads are enormous anyway, so I don't think we're going to have any problem with that, but I'm going to pick the 24mm just because. Don't use the one that's already there. Ah, yeah, see there's a little piece of track already there, and so it kept size. Don't want to do that, want to do that. I think that looks fine. Bring the silk screen to the top again. Look at all these. That all looks okay. Let's look at that ferrite bead on the 3D view. That looks okay to me. And again, I can look at the real thing. I'm just off screen here. Yep, no, that looks fine. Do I have any more vias fouling my silk screen? Scrolling around, and we haven't looked at the I/O circuit yet. We did down here. These seem fine, these seem fine, these seem okay. 2, 3, 4, we are. Check my silk screen is all in line. Yep, that's all lined up, looks fine. No need for those traces to be quite so close together. This is the problem, I go in to fix one thing and then I end up just fiddling with it, because you can always push a trace just a mil here or there and make the board slightly better. It's a terrible waste of your time. It's not a good thing to be doing, but once I see it, I can't help myself. These are all... what are those signals? I think those are just buttons. Yeah, not bothered about those. Hard to space. I'm looking at these and thinking they're not spaced evenly. That's because these are all 0.1 inch pitch, and then this extra one here is, where's that come from? That's an IRQ, and it's snuck through the middle there, which means these are then not evenly spaced, but I'm still going to we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6. Would anyone notice this detail? No. 2, 3, 4. 1, 2, 3, 4, 5, 6. Nope. Nobody will care that those have been rearranged to be the same distance apart, but I noticed it, so now I have to fix it. And again, I probably need to stop now. I think this is all fine. Remember what I came here for. I came here to move the vias so they're not on the silk screen. Oh, and as I say that, I found another one. I can stick that there. That's just a connector labelled with the voltages. Do think we've got them all. Inevitably, I will go and submit the job and then immediately find more. Oh, there we go. There is more V as I move. Right. What am I going to do here? So these are the pull-up resistors for the keyboard, just as I thought I was done. I think I'm going to have to move these to the corner again, just because it gets them out of the way. They're a bit close to the... no, I can't put them on the corner because I've got traces coming through. Instead, I'm just going to pull them down like that. And that's going to foul the connector. Fantastic. I'm just pressing M and R. I'm going to stick that number on its side. I'm going to put that there. I'm going to put that there to match, and then I'm going to rotate these two. So that's that one, and that is that one. Now, is that the best way to do this? I don't know. We might need to put a little line on again just to indicate that that is that one. Right, I've said I'm finished twice now, and then immediately went and found some more. There's another. So that isn't even. What's going on there? Ah, right. I wondered why this ground via wasn't next to the pad, and that's because this trace was coming in. So let's fix that by going that way. Move that there, and then that will come in lined up with that. I think that's going to be fine. It's only the yellow circle that is drilled. The white outer is copper plated. I don't think they're going to be drilling through silkscreen. Oh, well, not drilling through silkscreen. The board's already drilled. The problem is trying to paint silkscreen on top of a hole. The silkscreen will fall down the hole. There's another one. Stick it on the corner like that. Press B to refill. That'll just redo the pores. The pore we're looking at is on the bottom. Yeah, I don't know how I feel about these 2040 pin labels. They're kind of useful. They're deleted on this side because the DAC's too close. You don't need to probe them. It's all VGA ... Just keep probing around. It's all just H-sync, V-sync, ground, and then 12 bits of colour. I2C at the bottom. I think that's fine now. I don't know how I feel about... I have to make that one wonky, otherwise it bashes into that label, and I felt like that one should be matching. But it could be straight. I'm going to leave it. I've done enough. I've got more important things to do. Go and eat my dinner. Get this committed. That's the next step. Right. As always, we save. We run the GRC. Everything looks good. We're then going to go into the terminal. Actually, we don't want the release 1.1 branch. We want to git checkout develop, git checkout -b fix silk screen via overlap. We are going to git add KiCAD Neotron Pico PCB and that. Let's just have a look in a Git tool. pop that on the screen just to see what we're changing. So this one, what have we done? Oh, we changed a bunch of layers, auto track with visible layers. Nobody cares. Let's just unstage that and discard those changes because that's not relevant. This one, yeah, that's all the labels and stuff we've moved, so we do want to commit that. And then we're going to add a commit message, moved vias add, so they don't overlap. Closes, and we're going to make a note of which issue we're closing. 145, closes 145. Commit, push, done. And then over here we're going to open a new pull request. We're going to that branch, it's going into develop. Develop is where all of the changes live. Yep, that looks fine. And we're going to let that run. And then as soon as the DRC and the ERC checks have passed and the build has run and it's not found any errors, then I'm going to come along and hit merge. Once that's merged, I will then rebase this release branch, and we are probably going to do a second release candidate. So that's it. That is a walkthrough of what I do as a software engineer with my PCB project. Catch you again next time.